All right, welcome back everybody. We are moving into project 8 of our Arduino Starter Kit. In this one, we are looking at a digital hourglass. Here we will be using LEDs as opposed to sands through time. And we'll use a tilt sensor, which, as you shake or move the board, is pretty much the equivalent of rotating over the hourglass from top to bottom, so on and so forth. So with that being said, like we've done in the past, this first video is going to be looking at the code. And in the next video, we will do a walkthrough of the actual circuitry. So with that said, the first thing that we're going to look at, we've got our setup and our loop like we always do. But the first thing we're going to actually look at is setting up the variables for the various pins that we're going to be using for output, as well as the pin that we'll be using for input. And the input pin reads from the tilt sensor, and the output pins are going to write to LEDs. So with that said, we have this LED 2, and this first LED is, you'll notice that the variable itself is declared as an int and not a const int. And that's because we're going to use this variable, this LED variable, throughout the program, and we're going to increment it as we want to step through the various LED pins that we want to write out to. And so again, kind of looking over to the right on the screen, looking at the board, right? So these are the pins that we're going to be writing out to. And with that, like I said, we're going to be reading in from pin 8. Pin 8 is what we're going to be reading in the tilt sensor from, and pins 2, 3, 4, 5, 6, and 7 are what we're going to be writing out to. Now, the thing about the pins and incrementing this LED variable is we're going to write out to an LED at a specific time, meaning that every, if you we'll look at a value later on, which is 600,000, which means every 10 minutes. And if you leave the variable there, it means every 10 minutes we're going to turn on the next LED. So we're going to leave the previous one on. So we would leave 2 on, and then we're going to turn 3 on, and then we're going to leave 2 and 3 highlight, power on. And then we're going to increment to turn the fourth the LED that goes to pin 4, we're going to turn that on, right? And so it's just an incremental value, and so that's why we don't have that initial LED as const. So with that being said, you'll notice that this switch pin, as well as the LED, they're both ints, and that gives us what we call a signed 16-bit number. And we'll talk more about the signed and unsigned thing in a little bit later in the video, but essentially, regardless if the integer is signed or unsigned, you have 16 bits, which means the variation in numbers is the same for both signed and unsigned. The difference is a signed value can go to -1, -2, so on and so forth. But that also means that the largest value that you can get from a signed integer is smaller than the largest value you can get from an unsigned integer. Again, we'll look more at this later, but that's something that is going to be very important in your embedded development career. So I just wanted to point that out here, that every time you see int, those are 16-bit signed numbers in the Arduino development environment. Now here, you'll notice that we have a variable previous time, and that is an unsigned long, meaning we now have a 32-bit variable that we want to pay attention to, but we don't want it to be signed. We want it to be unsigned, meaning the smallest value we can have is 0. But that also means that the largest value that we can have, 32 bits, a huge number, 4 billion and something. So if we had this signed, the largest value we get is 2 billion and something. And the smallest would be -2 billion. But with unsigned, we get all the way up to 4 billion, but we only get all the way down to 0. So those larger numbers, if you need them, they come in handy. And in this case, when we start talking about timing, right, and you're incrementing a timer 1,000 times a second or 10,000 times a second, depending on the processing speed of your CPU. If you have a small value for trying to calculate up time, you're going to run out of numbers very, very quickly. And so with this program, that's why we're looking at the difference between signed and unsigned, because we do quite a bit with time here, and we'll see more of that later on as we progress through the code. So here we have our switch state and our previous switch state, and when we look at the tilt sensor, all we're trying to do is figure out if the last time that we read in from our tilt sensor, if the angle was different than it currently is, right? And this is how we know if the board is being moved or twisted or tilted or whatever it is. And we're going to do a comparison of, hey, what's the latest value? Is that different than the previous value, right? Is the current angle different than the previous angle? And so that's all that we're using these switch states for, and that's pretty straightforward. But you will notice that they're both set to 0 the very first time, which is going to help us initialize the board and lighting up the proper LED in sequence. Now here, you see this very large value, 600,000. And this value represents the time duration between an LED being turned off and getting turned on as the time ticks down, or in this case kind of ticks up. But when the very first time you light up the LED that's connected to pin 2, it will be 10 minutes before you do that. And then the next time that you light up the next LED that's connected to pin 3 will be another 10 minutes. And if you want that, right, and then this gives you a full hour. It's perfect. You'll see later on when I do the demo on the board, I change this value down to 600. So it changes, the LEDs light up on just a little over half a second. But I didn't want to wait an hour to show you a video of LEDs lighting up. So, but this is one variable that I just wanted to kind of point out, and you'll see its purpose here in a little bit. But you can change this to see more activity on your board at a shorter time interval. So with that being said, we now have another unsigned long, and this is the current time. Again, they set the unsigned long actual variable declaration inside the loop. Again, I don't like that. There's no need for it. Just update the value to the same variable. It's more efficient. So I moved the current time out of the loop as they have it in the book. But again, it's the unsigned long, very much the same that we had with the previous time, because here we're doing a lot with the timing to determine if some of the LEDs need to be turned on or turned off, so on and so forth. So now, jumping into the initial setup in the for loop, you can see here that we are going from our pin, which is equal to LED, which in this case is 2. So we're going from pin 2 up to pin 7. And so as we look at that, we're just going to keep incrementing, right? Keep on incrementing the pin value. And as long as the pin value is less than the switch pin, and the switch pin is set to 8, so as long as it's less than 8, which means the largest value we can get is 7, set up that pin as an output pin. And these are the outputs that we're going to be writing out to the LEDs. Now, the only other thing that we need to do here is set up the pin for input from the tilt sensor, and we're just going to do that outside of our for loop, and we're essentially saying pin 8 is now an input pin. That's pretty much about it. So that's all we need for our setup function. What I want to do now is take a look at the loop function, and really, right, again, we're just kind of shrinking down some of the code that's in the setup. It's not going anywhere. It's just I want to have an opportunity to really focus in on the loop function. So we'll go ahead and get that kind of expanded out here on the screen. And the first thing that we're going to do inside the loop function is look at the duration that the board has been running since we've plugged it in. You can see here it goes into the current time, which is the unsigned long. And from there, the very first thing that we're going to do is say, hey, is the current time minus the previous time. And the first iteration of this loop, previous time is set to 0. So current time minus previous time is current time. If it's greater than that interval, which was in our case 600,000, which it's not, then you would fall into this iteration. So every 10 minutes, essentially, you would fall into this conditional. And when you do ultimately fall into this conditional, you're going to set the previous time set to the current time. And all this gives us is an allowance of every time we iterate through this loop to have a valid previous time to compare against, right? If we left it at 0, it wouldn't make any sense. So the first thing we're going to do once we fall into this conditional at 10 minutes is say, okay, the previous time is now set to current time. So that means I'm setting myself up for success the next time I come through this loop. And then what I'm going to do is I'm going to set the current LED to high. And right off the bat, the first 10 minutes, the LED is going to be set to 2 because we haven't incremented it. We haven't done anything to it. So the very first time, it's going to be 2. And so we're going to set that LED that's connected to our 2 pin, we're going to set that to high. Now, once we do that and we set that pin to high, we are going to want to increment that LED so that the next time, 10 minutes later, that we hit this conditional again, then we'll be lighting up the LED on that's connected to pin 3, right? And so that's all that this initial conditional is doing. What we need to do here, the very next thing, is read in the tilt sensor. Is the state of that tilt sensor, is that the same as it was previously, or does it have a new angular momentum to it, right? Is the board being turned? That's what we ultimately want to look at. But before we can do that, we have to get the current state of that tilt sensor. So once we read that in, now we go ahead and we look and we say, okay, what is the current switch state based off what it was previously? This switch state from a tilt sensor is what's the angle that you were sitting at previously, and what's the one that you're currently sitting at now. And I guess this is from an hourglass perspective, have we turned it over or not? Now here, once we see that the state has changed, now we're saying, oh, wow, somebody's moving this thing, right? So it's kind of like flipping the hourglass over, and you're kind of resetting the sands of time, if you will. And you'll notice that we start at pin 2, and we once again go through pin 2 all the way up to the next pin, next pin, next pin. As long as the pin is less than the switch pin, which is 8, so we go from 2 to 7, we go ahead and set that to low. That means that every time you re-angle the board, you're setting all the LEDs back to turned off, right? And you'll be waiting till the next iteration to turn the next switch back on. Now, the first thing you need to do is make certain that the next time you do want to turn an LED pin on, you've set your LED variable back to 2. Who knows where it was, right? It could have been on pin 5 when the board started moving, or it could have been on pin 7 when the board started moving. Who knows? And so this way, we just kind of say, okay, set everything back to pin 2. So next time I want to turn a LED on high, I'll know for a fact that I'm starting at pin 2. And after I turn it on high, then I'll go ahead and increment that value again. And so here, the next thing that we do, like we did before, is we set the previous time to the current time just to make certain that we can come through, and every time that we're trying to figure out how long we've been active, so we have that 10-minute interval, we have the previous time that's valid, right? So we can do an honest comparison against it. And then the only other thing that we need to do is set the previous switch state to the current switch state, meaning, you know, if it's at 90 degrees and our previous one was 85, go ahead and set the previous one back to 90, so that way if the board starts moving again, right, we've reset it properly. And so we can detect motion that way. And so that's all that there is for this code base. The only thing I want to do really quick here is talk a little bit about signed and unsigned. And with that, you can see that we have two variables here, right? We have an int of signed var. I just named it signed var for clarity. And then we have an unsigned int. That's an unsigned var. And when you really kind of start to look at these two, they're both integers, right? I didn't do an unsigned long. I just did unsigned int. And so basically what the difference here is a signed 16-bit variable and an unsigned 16-bit. But they're both 16 bits, meaning that the full span of numbers is identical. It's just what the maximum and the minimum values actually can be. So, what I want to do is take this down from 16 bits and let's just talk about 3 bits. I think that will help clarify some of this for anybody who might be a little bit lost on this. If I have 3 bits, and we've seen the binary numbers in previous lessons, if I have 3 bits, I have 3 ones, right? And that comes out to 111 base 2 is 7 in base 10. And we count in base 10 every day, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? We count in base 10. And so if I look at having 3 bits that are unsigned, the largest value I'll have is 7, and the smallest value I'll have is 0, right? If they're all 0, 0. If they're all 1s, 7. Now, just as we have 111 is 7, it's not -3. We'll talk about this in a minute. And just as we have 101, which is binary 5, but that's not -1. And the reason it's not -1 is because we have an unsigned number that we're looking at. And right now I'm looking at bullet point number 2. 111 is 7, and 101 is 5. But when we talk about signed, then we have 11, which is binary 3, and we have 01, which is binary 1. And we look at that leading bit as a sign. If it's a 1, it means negative, right? So that'd be -3 or -1. So that's what we're kind of looking at. And down at the bottom, once again, you'll see that, the way that 111 works out is if it has a 1, then there's a value of 2 at that position. So if you look down at the very bottom, I have 111. So there's a value of 2 at every single position, the 0th position, the 1st position, and the 2nd position. So that means as a unsigned, I have the number 7. However, if we look a little bit over and again at that last bullet point on this page, we look over to the right. If I have a signed value, then the only thing I can really pay attention to is the first 2 bits. In this case, the bit at the 0th position and the bit at the 1st position. So 2 to the 1st plus 2 to the 0th equals 3. And then that means that the leading bit, if it's a 1, it's a negative, and if it's a 0, it's a positive. And so that's really what we're looking at. And so here you can see that if we have 3 bits unsigned, our maximum is 7, our minimum is 0. And if we have 3 bits signed, our maximum is 3, and our minimum is -3, right? And so if you want to count above 3, you need to make sure that it's not signed. Or give it more bits, whatever it may be. So again, just kind of taking a look at this, right? 111 is -3, 011 is 3. These are both signed. And again, 101 is signed of -1, and 001 is +1, right? So we're looking at the negative and the positive based off whether or not that first bit is set. So anyways, wanted to bring that up. I know it made for a little bit longer of a video, but I think it's important that you understand the signed components or the signed variables for the embedded environments that you're going to be in, because they're going to become very important as you move through your development kind of growth and maturity. So anyways, enough about that. Now that we've taken a look at everything, we will next we'll walk through the actual board itself and see some of the LEDs light up as we kind of tilt the board left and right, up and down, whatever it may be. All right, so we will see you in the next video. Take care, everybody.